Lesson 3, Surf and Turf, Investigating Radiation of Land and Sea. Key terms for Lesson 3. Visible light, electromagnetic radiation that can be seen with the human eye. You can look at the picture. We learned a lot about this last year in our light unit, and you can see the Roy G. Biv on the spectrum. Wavelength, the distance from crest to crest or trough to trough. Again, wavelength should be reviewed from last year. You can see an example of a shorter wavelength and a longer wavelength. Solar energy, solar radiation from the sun. Earth's energy budget, the way solar radiation is used on Earth. Take a second to look through this picture, and it shows the percent of the solar radiation and how it's used once it hits the Earth's atmosphere. Infrared radiation, wavelengths longer than visible light waves. Ultraviolet radiation, wavelengths shorter than visible light waves. So visible light kind of fits right between these two on the electromagnetic spectrum. So last year we really just focused on learning about visible light. Now we're going to look at two other sections that are on each side of visible light. And as you can tell, the red, infrared, is right next to the color red on visible light spectrum. And then ultraviolet is right beside the violet, which we learned about on the visible light spectrum. So these two types of radiation we cannot see with our eyes. We have to have some sort of instrument to help us see it. So here are two examples of what objects would look like with that radiation reflecting off. So we usually just see the visible light reflecting. So if we had infrared reflecting, that's what an elephant would look like. And then to the right is a picture of a mineral under ultraviolet light. Convection currents, the movement of molecules in fluids, not solids. So this is really between liquids and gases, and you can see the example here. You see this on the coast where there's water and land, and you can see how warm air rises up and cool air will fall down. And you can see that the cycle kind of reverses at nighttime. And this keeps the air moving. Link. Have you ever walked barefoot on the beach on a hot, sunny summer day? How did the temperature of the sand compare to the temperature of the water? What about walking on the beach at night? Which felt cooler, the sand or the water? The sun heats the Earth's atmosphere. This energy travels to Earth in electromagnetic waves. Most of the solar energy that reaches the Earth is in the form of visible light and infrared radiation, and a small amount of ultraviolet radiation. In this lesson, you will observe what happens to the temperature of sand and water when they are exposed to heat for a given amount of time. This model will help you understand the effect of the sun's radiation on Earth's land and water and how air convection currents, wind, are created. So right now I want you just to make a prediction. Which do you think will heat up faster, sand or water? Go ahead and write in your notes why you picked that one. So I will explain to you what happens. Heat from the sun will transfer into solids faster because their molecules are close together. It will take heat the longest to transfer into gases because the molecules are spread apart. Solids also lose heat faster than gases because their molecules are close. Think about a hot sandwich and a hot drink. Which loses heat, cools off faster? The sandwich will. So look back at your prediction now between sand and water and see if you'd want to make any revisions to what you originally thought with this information. Well, so the sand will heat up faster, but it will also cool off faster than the water. What about a gas? It would even take longer to heat up the air compared to the water and sand, but the heat would stay around and it would take the air longer to cool off. So here's two questions I want you to think about and record in your notebooks. How do land and water compare in terms of energy absorption? So remember, absorption is a word we learned last year. It means to absorb the heat. So how would you compare land to water? How do differences in the heating and cooling of land and water produce air currents? Wind. So how do you think these would start creating wind? Those of you who have been on the beach, you usually can tell there's a stronger wind when you get down closer to the water. So why do you think this is happening? If you need to hit pause, you can go back to the diagram of convection currents, and that might help you get an idea of how the air is moving and forming wind. So to get some more background knowledge on UV rays, radiation, and convection currents, check out the other videos that are on your Blackboard site. Once you finish watching all the videos and you learn a lot new information, you can go through to your reflection and go into the discussion board after you finish viewing all the videos and type in what you've learned, and make sure you're specific in what you write about as we read through and see what you learned as teachers.